back in Space Station Phase B, which is when I started, we were just starting to take a look at the technologies that we wanted to use for the environmental control and life support systems. And we tested various candidate technologies in ground test. We tested them by themselves. We integrated them together. Ultimately, this resulted in a comparative test program back in the early 90s where we took the leading candidates for each function, functions being air revitalization or water processing. We took the leading candidates, we tested them head-to-head against the same conditions, and we got the results, we analyzed the data, and we ended up making recommendations to the prime contractor, Boeing, from NASA as to, hey, we think these are the technologies we should fly on space station. And Boeing actually took all of our recommendations, and that's how we ended up selecting the technologies that would go into the ECLSS. So once we selected the technologies, we had laid out a test program that included 3 phases. They were called the POST, the BOAST, and the MOST. Now those stood for pre-development operational system test, then baseline operational system test, then finally manned operational system test. And each of these test programs was supposed to take all of the technologies, integrate them together into the entire system, and run through test. So and increasing fidelity, finally with humans in the loop. In hindsight, we only had the budget to complete the first phase, the POST. We did that test, and after that, budget cuts forced us to abandon the BOAST and the MOST. And so we essentially had to go from that test program into producing flight hardware, and the flight hardware was never really integrated together again until it saw the flight element, the U.S. lab in testing down at Kennedy Space Center. So based on this experience, I think for exploration, in hindsight, these decisions left us with is hardware poor. We essentially wanted a hangar queen on the ground, and we weren't able to do that. We were supposed to have been left with an entire integrated system, which then we could have on the ground. In reality, these decisions left us with very little hardware. Since then, we've been able to pull together pieces of qual hardware, pieces of development hardware, and to the best of our ability, build that system for a ground system. But I would recommend for future exploration missions, this is not ideal. I mean, you definitely want a robust ground system to have in case anomalies come up on orbit that you need to do testing with. Excellent. Another really valuable thing we did along the way was we took a couple of components of our ECLSS system that we thought were going to be susceptible to microgravity, and we flew flight experiments of those components on the shuttle. Those included our urine processor, which is essentially a centrifugal rotating drum. It's very complex. And a part of our water processor, the catalytic reactor piece. And those flight experiments were very valuable in teaching us, validating the way we designed it was going to work in microgravity. As we go forward, we absolutely need to do the same thing. We need to use the space station, now that we have it, as our test bed. And it is the perfect test bed for advancing our ECLSS systems for future exploration missions. And we need to take all of the advancements that we want to make to the ECLSS systems, validate them using the space station, and prove them out before we take them to future missions. So when we put together the U.S. lab element with the entire integrated system, including the ECLSS, the avionics, everything that was going to go into it, this was a full end-to-end test at the Kennedy Space Center. This was the flight element. Because we couldn't put any humans in this module, we had to simulate the metabolic loads that were going to be on the ECLSS system. So, for example, instead of humans breathing, we had to inject carbon dioxide and then have an oxygen concentrator that would remove oxygen, inject trace contaminants that the human body would normally give off in order to test our systems there at Kennedy Space Center. And that was interesting and challenging. It's important to note that this end-to-end testing is absolutely critical before we fly future exploration missions. Not only was it the first time, in some cases, that the flight hardware met the flight software, but just everything integrated together is critical before you fly that element.